Okay, now we go to fundamental problem 10.8. In this case, you have this kind of shape, cross-section shape, right? Of course, it's a beam, and then this is the cross-section. You have this length, the base is 150, this height is 30, okay? And then you have this this one which is 30, okay, the base, and the height is 150. I mean, if you take this x prime like this, okay? The question asks you to find what is the moment of inertia about this x prime axis which is passing through the centroid. So actually here, this is although actually the question gives you the hint, okay? But generally speaking, what you have to do is something like that, alright? You might not be given this axis, right? And then the question asks you to find find the moment of inertia about the centroidal axis. Okay, so you have to determine what is the centroidal axis. Okay, for instance, in this case, it's somewhere here, right? And then only then you find I about this axis. Okay, so how do you find this centroidal axis? Of course, if you look at the question, it is mentioned that this distance is y bar. So you know y bar from chapter 9, right? Your centroid, right? So this is y bar, of course. I mean, given in the question, but the thing is, like I said, normally you are not given this. You need to understand that you need to find where is your centroid first, right? Because when you do moment of inertia, you need to know where is your centroid. Otherwise, you cannot do it correctly, right? So, how to find this? So, though actually this is in chapter 10, which talks about the moment of inertia. For this first part, you need to go back to chapter 9, alright? How to find this y bar, alright? So, to find y bar, for this composite area, okay, y bar is given as y tilde a over equation of a. Remember that? So basically you have two areas, one is this, and one is here. So the first area, the centroid is here. Second area, the centroid is here, which is half of that and half of this. Alright? Okay. Rest of the time, this is the first area, second area. We'll talk about that. Alright? Of course, in chapter 9, you make tables. You make a table, right, to do this, but you're going to do it here. So make this as a reference axis, right? This is y equals to 0. Whatever value you go up, and then you have that value of this y bar. Alright? So this y, for this area, the first one, that's the whole summation. What is this length? This height? It is 15, isn't it? 30, half of that, 15. Alright? This is the y tilde 1. Okay. And then this is the y tilde 2. Area number 2. Or A and B, what doesn't matter. Okay? So this is 15 y tilde A. Area is 150 times 30. Okay, 150 times 30. Alright? This is for the first area. For the second area, what is the y tilde? From this to the centroid, right? The centroid is half of 150. Is it okay? 75, 75. This is 75, alright? But it's not 75 because you need to measure from the y equals to 0, alright? So 75 plus 30, which is 105. I hope you can follow this, right? The centroid here, for the second area, it is half of 150, which is 150, 150, in the middle, right? But this one is not 150, sorry, not 75. You need to measure it from this reference axis, y equals to 0. So you need to add 30. 30 plus 75, okay? Because it is measured from here. So 30 plus 75, it is 105, okay? This is y tilde for 2. And then the A is 30 times 150. E times 150. Alright? And then the area, summation of area, simple, 150 times 30. Okay, 30 and 30, not 3. 150 times 30 plus 30 times 150. Alright, so you hit the calculator and then you will find your y bar equals to 60 millimeter, which means that this is 30 and then 30, right? You understand that? 60 meter from the bottom. So this first part, it is from chapter 9. But you need to understand this. Otherwise, for composite area, if the question comes out like this, you know how to use I, you still cannot answer it. You need to understand chapter 9 first, right? The centroid, how to find the centroid. Okay, next, after we know this, then we can do this I, x prime, okay? Because now you know the location of your x prime, which is the axis which passes through your centroid, right? So for this composite area, your centroid is where? It is here on the 60 millimeter from the bottom, right? And then this is your x prime, your axis that passes your centroid of the whole area, alright? The whole composite areas. Okay, so again you have two areas, one at the bottom, right? And then the one is the one at the top here. So you can choose which one as your first area, doesn't matter. For instance, you take the bottom one as your first area. So first you do moment of inertia about its own centroidal axis, right? Which is 1/12, base 150, height is 30. Is it okay? I mean this area, 1/12, base 150 times 30 cubic, base and height, base times height cubic. Alright, but this one is not just that. The reason is because if you do only this, you only find the moment of inertia about its own centroidal axis, this axis. Alright, not at this x prime axis. Right? So what you have to do is you have simply plus AD squared. Okay, again, I x prime equals to let's put it away. I x equal to I x prime plus AD squared. Okay, its own central axis plus AD squared. A is its area, D is distance between its central axis, the axis that you want to find ownership about. Right? So the area is 150 times 30. Alright. The D is what? The D is how much is between this and that? You know this is 60, right? You know this is 15. So subtract them. 60 minus 15, okay, because it's half of 30, right? This y1 till there. So you got 45 squared. The D is 45. Alright? This one is for the one at the bottom. Right? The one at the top, so same, plus 1/12. The base is 30, right? The base is 30. The height is 150. Alright? 1/12. Why over 12 h cubic again? Because this is a rectangle, right? So 1/12 b h cubic, okay? But this one, for this one, it is just about this, its own, we call it neutral axis, okay? The axis that passes the centroid, okay? Not here. So you have this gap, right? So to find this I with respect to another axis, okay? In this case, it's x prime. So you have to plus with the AD squared. So A is the area, 30 times 150, right? 30 times 150. D is how much? How much is D? How much is D? Okay. 150, 30. Total is 180, isn't it? 150, 30, 180. 180 minus 60 is 120. Is it okay? Wait. 150, 30, 180 minus 60, 180 minus 60 is 120. Okay. Okay, from top to this x still there. Sorry, x prime. Alright. So what is this distance? 150. The centroid, the blue one, the centroid is 75, right? 75, 75, isn't it? Sorry, 75, 75. Okay, so 120, 75. So this one is 120 minus 75, which is 40, 45. Alright, where is the blue color? So it is 45. Distance 45. Okay, I hope you can follow that. 120, 75, half of that, right? Half of the 150. So 120 minus 75, it is 45. Right? So you hit the calculator, you will end up with your I x prime as 27 10 power of 6 millimeter to the power of 4. Alright? Okay. What is the difference between this F108 with the previous examples, like F105 and F106, for instance? What is the difference? The difference is, in this case, you have to find the centroid first, the centroid of these composite areas, right? So you need to go to chapter 9 to find the centroid first. Only then you find the moment of inertia. Okay, most of the case, not most of the case, I mean it depends on the shape, but okay, just you need to understand chapter 9 first, alright?